Hi everyone, and welcome to our video on basics of programming with Python. In this video we will be exploring operators, functions, variables, and data types. These are common fundamental concepts for any programming language. Before we get started, let's set up a minimal environment for learning. We could use Terminal and run Python in an interactive mode, but it's a bit of strain. By default, Terminal lacks aesthetics. It is essential that you become proficient in using Terminal, the command line interface. If you stay steadfast with your programming journey, you will soon reach to a point where GUI-based point and click is not very productive. Graphical user interface could slow you down and can be distractive. As we progress through our tutorial series, we'll be covering terminal customization in a future video. For now, run idle, Python's integrated development and learning environment. If you don't have idle installed, please watch our tutorial on how to install Python. You can find the link in the info card at the top right of this video, or in the video description below. If you prefer, you can adjust the font and window size from the settings. Press Command and Comma to bring up the settings. This is a system-wide macOS keyboard shortcut. Let's dive in and explore the different types of common operators we have in Python. Operators are something you already know, and we are going to build and expand on top of that. When you run idle, it opens up a shell with Python interpreter in interactive mode. You can test and see how the math operators work. The addition, subtraction, multiplication, and division. These are called arithmetic operators. Furthermore, you also have floor division, which will give you nearest rounded value in a division. Modulus, which will give you the remainder in a division. And finally, the exponential operator, which will give you the power of value. For example, 2 to the power of 3, which will give you a result of 8. Now let's move on to comparison operators. A type of operator that you are probably familiar with. Check equality with the symbol of double equal sign. Not equal to is denoted by an exclamation in front of equal sign. Then you have greater than, less than, greater than or equal to, less than or equal to. Test few combination to clearly understand how the comparison operation works. We get an extensive set of operators in Python, divided into groups based on its type. You can use this chart as a quick reference. There are 7 types of operators in Python: arithmetic, comparison, assignment, logical, membership, identity, and bitwise. The operators highlighted in green are the ones we'll be covering. Other 3 are part of advanced topics, for which we'll be doing a separate tutorial series. Now let's look into functions in Python. In its basic form, functions are actions, like print, sum, open. Functions allow you to organize your code into reusable blocks, abstract away complexity, and make your code more readable. There are 6 types of functions available in Python: built-in, user-defined, recursive, lambda, generator, and decorator. We'll explore most commonly used built-in functions, and then look at how we can define our own functions. Similar to operators, rest of the function types are intermediate and advanced topics, which we'll be covering in a separate tutorial series. Now let's see some functions in action, starting with the print function. Switch to idle, and at shell prompt type print, open parentheses, quote, hello, comma, space world, quote, and close parentheses. Let's take a moment to examine this line of code. Printing hello world is the most simplest and canonical application you can write. Even though it's just a single line, press return, and Python shell will print hello world back to you. Idle's color coding helps us with better readability. Let's take a closer look at print function. We have the function name, which is the print word, then an open parentheses, then hello world in double quote, and finally the close parentheses. Now let's remove the hello world part from it. In its basic form, this is how print function looks. A function name, open parentheses, and a close parentheses. And this is how you invoke, or call, any function in Python. You may have noticed that we have removed double quotes as well. Quotes are used to type text in Python, and you can use single or double quote interchangeably. It is recommended to stick with one of them. Python's documentation uses single quote. Let's bring hello world back into print function. Whenever we provide a value into the function call, it's called an argument. Within this print context, hello, comma, space world is the argument. And as we previously mentioned, quote is used to type text in Python. Additionally, you will come across a term called parameter, which get used interchangeably with argument. There's a subtle difference between argument and parameter. Argument is the value we give to the function, and parameter is what the function can take. Print function can literally take 0 to infinite number of parameters. But in our example, here we have only provided one argument, hello world. As we just mentioned, print function can take no argument. Switch to idle, and let's type print function without any argument, and press return. We gave nothing to print and we got nothing. Now let's try printing with multiple argument. We do that by separating the arguments with a comma. Type print open parentheses, hello inside double quotes, a comma to separate the arguments, and then world inside double quotes with closing parentheses. Press return to print. Now let's print hello world as a single argument. As you can see, the only difference in both the output is a comma. In the first print statement, comma is outside the quotes, which gets treated as an argument separator. And in second print statement, comma is part of the text. Anything inside the quotes gets treated as a text in Python. Now let's print again the hello world as two arguments, with a comma after hello. As you can see, there is no difference in the output. Only difference is in how we have provided the argument. Up until now we have only looked at printing text. Print function can take wide set of parameters. Let's try printing some numbers as a single argument, and also passing it as multiple argument. We could also pass arithmetic operation as an argument, like 1 plus 2, 3 minus 2, etc. Furthermore, we can pass comparison operation as well. Greater than, less than, and so forth. Switching back to our hello world example, let's see if we can make it a little interactive. All this time we have been telling what needs to be printed. How do we give that choice to our end user? We need a way to get what the user would like to print. And Python does have a built-in function just for that, called input. Type input with a pair of parentheses and press enter. We will be prompted to give the value we would like to pass into the program. And when we type in and press enter, the value we gave will be printed back to the screen. Let's take a closer look at input function. The mechanism by which we got the value printed back to the screen is called return value. And that's what input function does. It takes the value user typed and returns it back to the caller. In this instance, the caller is Python shell inside idle. It's important to understand that input function always returns value as text. Even if we type number, the return value we get from input function will be a text. As you can see, what we get in return printed on the screen is inside quotes. And we know in Python anything in quotes get treated as a text, irrespective of whether it's in single or double quote. Python's documentation and interpreter always uses single quote. As we just learned, input function takes whatever the user provides and returns the value back to the caller, always as a text. So how about we test this return value with the print function? Let's try calling input inside print. Only difference we have from our previous learning Py input statement is that we don't have quotes when the value is printed back onto screen. How about we apply this to our hello world example of print function? We'll pass hello comma as one argument, and input function as a second argument. It works, but it's not a good practice to call input function inside print. Also, it's not a good design if we have to repeat same thing again and again. Any situation where you have to repeat multiple times is a good indication that there is an opportunity to improve. Let's start with the tool we have been using. Idle opens a shell with Python's interactive mode. Interactive mode is basically something called REPL. R-E-P-L. Read, evaluate, print loop, which helps us to experiment and learn. If we want to write a Python program, all we need is a text editor. Type the code, and save the file with .py extension. Let's close and reopen idle. By default we get the shell with Python interpreter in interactive mode. From within idle, open the text editor by clicking the file menu, and then new file. Or you can press Command N to open a new editor. Arrange the open windows however you see fit. We prefer to have the editor at the top, and shell at the bottom. Let's try printing hello world. Relatively similar to in a proper development environment. Type the print function, and give hello world as a single argument. And now if you press the return key, the cursor will move to the next line, like any text editor. and you will not see any output in the shell. In order to run this program, make sure text editor is selected, and click Run menu. Then run module. Or you can't press F5 on keyboard. Idle will prompt you to save the file. Click OK, and type in the file name. And click Save. Once the file is saved, the program will get executed, and will print Hello World at the shell prompt. You may have noticed the restart message, with the path to Python program we just saved, at the top of Hello World. Key thing to note is that the program is saved with .py extension. And this is how we always save a Python program. Now let's test out few print statements. For a change, let's print Hello Python, and press F5 to run it. You will be prompted to save the file. Whenever you make a change to the file, Idle will prompt you to save it before you run the program. You can click Save from File menu, or press Command S on keyboard. Click OK to run the program, and at the shell prompt, both Hello World and Hello Python is printed. This is how a Python program gets executed, from top to bottom, line by line, and the empty lines in our program file gets ignored. Now let's add some print statements to print numbers. We'll pass it as a single argument, as well as multiple arguments. You may have to scroll up the shell to view the results. Let's add another print statement. To print text, which we'll provide as multiple argument, and press F5 to run the program. Now clear all the print statements except the Hello World. As previously mentioned, this is a text editor. We can select the lines, and press Delete to remove. And let's look at how we can use input function. Move print function down a line or two, and type in the input function above the print statement. When we run the program now, we get prompted to type in the message we want. And when we type it, nothing really happens. The program stops after printing Hello World, which we typed in our code. We can make this program better by switching to a previous approach we took, which is to pass the input function as a second argument to print function. And if we run the program now, it will work as expected. But as we explained before, it's not a good practice. And for example, if we have to ask the user for their name every time we need to use it in our program, is not a very good design from a user experience perspective. We need a way to capture the user inputs and store it inside our program. This is where we need something called variables. Variable is basically a container to hold the data in memory. This is not a new concept. You would probably have learned in math, like x equal to 4, y equal to 7, and so forth. It's similar in programming as well. Since it's inside the computer, we can hold any type of data: text, number, image, sound. Pretty much anything computer can process. For now, let's set the foundation with text and numbers. You can declare a variable by giving it a name. Type in your chosen variable name, then type a single equal sign, which is called the assignment operator, and then the required value. There are certain rules when it comes to naming the variable. Names should only contain letters, digits, and underscores. Names are case sensitive. You have to be careful when you use uppercase and lowercase interchangeably, and it cannot start with a number. The very first character of the name should be a letter or an underscore. Now let's see the variables in action. We'll test it out in idle shell, and then write up our very first program. Let's try creating few variables back in idle. You can either try out your own variable names, or follow through. Type name, space single equal sign, and a space again. And for value, type John in double quotes. The spaces before and after equal sign is not technically required. It's mainly to make the code easy to read. And when you press enter, nothing seems to have happened. Behind the scene, the value John is now associated with the variable name, which can be seen by printing the name variable. Let's combine this into a greeting message by passing in hello, and this name variable is multiple argument to print. Result is what we have expected. In programming, the term variable has its literal meaning, something that could vary or change. Let's change the value of name variable from John to Jane, and print the name variable to confirm that it has indeed changed. Remember, we learned that the input function takes the user type value and returns it to the caller as a text. We can call the input function as part of the variable declaration by assigning it as the value after the equal sign. And when you press return, idle shell will prompt you to type in. Within Python's interactive mode, we don't need to always call the print function. To check what value a variable has, we just type the variable name and press enter, and shell will print the value. Open a new editor from File menu and Idle, and save the file with greeting as filename. Type in the code we just tested on shell, starting with the input function, assigned to name variable, and pass in text hello, and name variable, as multiple argument to print. Click Run Module from Run menu, and click OK to save the file, and continue program execution. And when it runs, we can notice that our program lacks context. All we have is a blinking cursor at the shell prompt. Since we have developed this program, we know what is expected. If anyone else runs this program, they will have no clue what needs to be done. Once we provide the response for input prompt, the message gets printed on the screen. As we just mentioned, we have an opportunity to make this program better by adding a context for input. One way to do it is to have a print statement before the name variable. Let's add that print statement asking the user for their name. Now if anyone run this program, there's a much better clarity on what is expected. We still have some room for improvements. In general, the less code we have, the better it is. If we read through the Python documentation for input function, we will know that input function can take a parameter called prompt. You may have noticed the tooltip we get whenever we type print or input function. Let's remove the first print statement, and also input function's parentheses. Now just type the opening parentheses of input function. To bring up the tooltip, type in the prompt and the closing parentheses, and run the program. We technically got the same result with less line of code. Additionally, there is a subtle improvement in output, as we can type the response in same line as prompt. Now let's say we are developing a program, which requires a minimum age to access and use. We will need to know how old the user is, and then compare and validate with the minimum age required. So let's declare the age variable and set it to input function, so that the user can type how old they are. And for now, let's print it back to the user. Running the program will prompt us for the name, and then age. When we type in the age and hit return, checking for minimum age will get printed. Then we get few lines printed back to us by Python interpreter, which is completely new to us. In Idle we get the message color-coded in red, which is an indication that there is a problem. Seems like we asked the computer to do something which it didn't understand. Let's read through line by line. Trace back most recent call last, which really doesn't make any sense. Then we have file, and path to our program file. Within same line as file, we have line 7. That seems useful. Then in module, in next line we have our print statement for checking the age. And finally we have type error : greater than or equal to not supported, between instances of str and int. Even though we might not be able to fully understand what Python interpreter is trying to tell us, we still have few things to move forward with, like the file to our program line 7 and the print statement for age validation. The option to show line number is in shell tab of idle setting. Let's read through our code now. Starting with line 7, that's where we have our print statement for age validation. We know print function works since other print statements are working. So let's check the argument we have passed to print function, which is age greater than or equal to number 16. If we double check the age variable, what we have is an input function, which returns what the user typed as a text. Let's take that and process the print statement for validation. So back at line 7 inside the print statement's argument, we are basically comparing a text with number, which is incorrect, and that's where the problem is. The message we got from Python interpreter is starting to kinda make sense now. But if we want to fix the problem, we need a better understanding of the message. Let's revisit the message, specifically the last line, which basically says we are trying to compare between str and int. Str stands for string, and int stands for integer. These are called data types. A classification of data based on the value it can contain and operate. Python provides few different kinds of data types. We'll start with the basic types, more of a primitive ones, which are integer, floating point, string, and boolean. Integer and floating point are numbers, which can be positive or negative. Differences in decimal point. Integer cannot have a decimal point, it can only contain whole number. And floating point will have a decimal point. Floating points are typically used for precision. Then string is basically a text. Technically it's a string of characters, and thus the name string. Finally we have boolean, something adopted as it is from mathematics. It can only have two values, true or false. Mainly used for controlling logic or making decision, as true or false can be transposed into yes or no. Data types helps us understand the meaning of our data, like name, which is a text, so in programming it will be a string. And age is a number. We don't normally use decimal point for age, so it will be an integer. Data types also helps us perform correct operation. This is the piece that was missing in our previous example of greeting program, where we ended up comparing age, which is a text, with the minimum age required, which is a number. It also ensures that the data is consistent and valid by restricting the value that can be stored in a variable. For example, once we declare a variable that can contain integer, we cannot change it to a string or a float. We only need to consider data types when we are carrying out any operation on a variable. And when we declare a variable, data types are taken care by a feature called dynamic typing. Let's say we are declaring 4 variables: age, height, name, and student. Dynamic typing feature of Python interpreter will figure out the data type of each variable based on the data we have provided. Python does provide us a function for each of the respective data type, which we can use to carry out certain operation, like converting between different data types. For example, we can convert a string to integer. Now let's switch back to idle and continue with our sample program. We just learned that we can convert between data types. Let's see if we can get out greeting program working without any problem by converting the age variable to integer. Here we are passing the age variable to in function and assigning it back to age variable. This is what a type conversion is. Let's run the program and see how it works. All looks good. We don't have the message from Python interpreter anymore. It's not a perfect program, and we'll keep improving it as we progress through this tutorial series. The goal of this video was to explore some of the building blocks and key concepts of programming with Python. Thanks for watching. We hope you enjoyed this video. If you did, please subscribe to our channel and hit the notification bell so you don't miss any of our future videos. We'll be posting new videos every 2 weeks, so be sure to subscribe so you don't miss out. We appreciate your support. Thanks again for watching.